This is Dr.D Govardhan, Professor at Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are covering the topic of linear impulse and momentum, conservation of momentum. Here let us consider an object which is subjected to the forces F1, F2, F3 and F4 as shown in figure. Because of resultant of system of these forces, the object is moving with initial velocity u, and after time t it is attained final velocity v. After an interval of time t, the distance covered is given by s now. Now according to the equations now, R is equal to m into a, where R is equal to the resultant of system of forces which are acting on a body is represented as R is equal to A, which should be equal to m into A now, where m is representing the mass of the body, A is the acceleration with which the body is moving. It is according to the Newton's law of second law of motions. But A means the rate of change of velocity. It is represented as dv by dt now. Hence, we can write R is equal to m into dv by dt now. On cross multiplication, we got R into dt is equal to m into dv now. Since we are considering the motion of the body from first position to second position now, at which it is having initial velocity u, final velocity after time t seconds is equal to v now, the distance covered is equal to s. Hence, the total, the momentum R into d theta is here called momentum now. M into dv is equal to rate of, it is a change in momentum multiplied by the mass now. Hence, the total change in momentum is given by doing the integrations from the limits u into v, and again R into theta is again integrating from 0 to t seconds now. The integration of 0 to t, that is R into dt, is called impulse, that is a force into time now. Hence, its units are Newton seconds now. And the integration of m into dv from the limits u and v, it is equal to m v u to v now. It is equal to mv minus mv. This m and v, it is called momentum possessed the body when it is motions. Generally, it is called the quantity that the quantum possessed by the body when it is motions now. Or here it is called a simple word momentum now. That is mv minus mu. It is called now change in momentum of the body now. mv is representing the final moment of the body. mu is representing the initial momentum now. That is R into theta integration from 0 to t is equal to m into v minus m into u. That is the impulse is equal to change in momentum now. Here, if R is the resultant force which is acting on a body, it is a vector quantity. It is multiplied by scalar time now. Hence, this R into theta is treated as the vector quantity, and the change in momentum, that is change in momentum, is equal to the final momentum minus initial momentum. It is also a vector quantity. Conservation of linear momentum. Here, linear momentum means when the body is moving in unit directions now, that in x directions now. Here we are taking now. Then the momentum possessed by the body here treated as a linear momentum now. That means the momentum can be represented in a unit directions now. The momentum of a system in a linear directions is always conserved. That means the momentum possessed by the body is always constant. So this is nothing but initial momentum we have taken R into theta according to our previous equation. R into t integration from 0 to t is equal to, we are taking m v minus mu now. That is conserved means the momentum possessed body at initial stage is equal to the momentum possessed by the body at final now. That is initial mean nothing but mu and final momentum possessed body after time t is given by mv now. It is a conserved means it nothing but remains a constant now. In order to get these values, it is called constant means the resultant force which is acting on the body should be equal to 0 now. That means R is equal to 0 means the left hand side equation is equal to 0, which is equal to mv minus mu, R which can be written as mv is equal to mu. That is the momentum possessed by the body at initial stage is equal to the momentum possessed by the at the final stage. Or the momentum remains constant. Here it is called conserved now. Only it is happened when the resultant of system of forces which are acting on a body should be equal to 0 now. Or in other words, the total momentum of system in a direction before the collisions is equal to the total momentum possessed the body after the collisions. A law of conservation of momentum. It states that the total momentum of two bodies remains constant after their collisions or any mutual action. That is, two bodies are there now. Here it is having, one is having m1, it is moving one direction now, and one more body there moving, having velocity. Its initial velocity is represented u1. Initial velocity is equal to 2. Just after time 2, they are now colliding with each other and separated by, again, with the velocities v1 and v2 assume. That is, before the collisions, the momentum possessed by the body is equal to m1, e1 and second body m2, e2. That is, sum of the momentum possessed by the bodies before the collisions is equal to m1, e1 plus m2, e2. After the collisions or after the impact, again they separated with the initial velocity, with the final velocity of v1 and v2. Hence, the final momentum is given by m1 v1 plus m2 v2 now. According to the law of conservation of momentum, the total momentum possessed by the bodies before the collisions remains constant after the collisions also. Or they are nothing but it is only happen now the resultant of force which is acting when they are in impact, it is be equal to 0 now. So it is represented as m1 e1 plus m2 e2. This is the momentum possessed by the two bodies before the collisions should be equal to m1 v1 plus m2 v2 now. Where m1 is representing mass of the first body, e1 is representing initial velocity of the first body, v1 is representing final velocity of the first body. Similarly, m2, u2, v2 representing the corresponding mass, initial velocity, final velocity of the second body. That is the conservation of momentum. It is taking place when the resultant force which is acting on the body should be equal to 0 now. Impulsive momentum method now. Now, sometimes the force, it may be act in two directions now. That means x direction and y directions. And the object is also not at all moving in linear directions. That is, when it is having two components, x component and y components, then according to the impulse momentum method, the impulse is the product of force and time, and also I told you it is a vector quantity, and moreover the force is here now vector quantity, time is the scalar quantity, hence the impulse, it is a product of force into time, is also treated as a vector quantity now. Similarly, in momentum now, the velocity is vector quantity and the mass is a scalar quantity. The product of mass and velocity is again vector quantity. Hence, when we are using rectangular coordinates, the momentum possessed by the bodies in x directions, which is equal to the change in momentum in x directions, as well as the impulse is given by the product of component of force which is acting in x direction multiplied by the time d theta. Similarly, in y direction now, the impulse, that is the component, it is the product of component of force which is acting in y direction multiplied by time. It should be equal to the momentum possessed by the body in the y direction. So that is equal to m2v minus v1 y now, where fx is representing the component of force which is acting along x directions. Time is the collision time, which is equal to the change in momentum in x directions. M, it is the mass of the body. M2x, it is the treated as mbtx, it is the change in velocity. It is the final velocity along the x directions. V1x is the representing the component of velocity in x directions. Similarly, V2y representing the final velocity in y directions, V1y representing the initial velocity in y direction. The change in momentum should be equal to the product of the component of forces which is acting in y direction multiplied by the time d theta. Hence, the resultant of force is given by the under root of fx square plus fy whole square, and the theta is given by tan inverse of sigma fy divided by sigma fx now. Okay, based on the change in momentum along the x direction and y directions, we are taking a small problem. A football of mass of 200 grams is at rest. A player kicks the ball which moves with a velocity of 20 meters per second at an angle of 30 degrees with respect to the ground level. Find the force exerted by the player on the ball. The duration of strike is 0.02 seconds. Here, the given data in the problem is the mass of the ball, which is equal to 200 grams, which is equal to 0.2 kg. Duration of the strike is given by t is equal to 0.02 seconds. Initially, the ball is at rest. That means the v1x is equal to 0. That is the component of velocity along the x direction should be equal to 0. And the component of velocity in y direction also equal to 0 now. And after the collisions now, the ball is moving with a velocity of 20 meters per second at an angle of 30 degrees with the ground now. Hence, this velocity is now, it is there, it is a vector quantity. It is represented into two components now, that is x component, y component. According to the figure, it is now moving, x component is moving towards the right hand side and y component is moving in upward directions now. Hence, v2x is equal to, that is the component of final velocity along the x direction is equal to 20 multiplied by 30 degrees is given now, that is along the x direction is equal to 20 into cos 30 degrees now. That is v2x is equal to 20 into cos 30. Similarly, the y component is equal to 20 into sin 30 degrees now. Here fx is representing the component of force which is acting in the direction of xx, and y is representing the component of force acting in y direction. Then according to the impulsive momentum equations, impulse is equal to into the product of force and time now. That is, when it is moving in a coordinate system, first we are taking along the x direction. That is the impulse that is acting in x direction should be equal to the change in momentum in x directions. That is fx into t equal to, that is the impulse along the x directions, that is the component of force multiplied by the time. It should be equal to change in momentum along the x direction, which is equal to m into v2x minus v1x. v2x is representing the component of velocity along the x directions after collision, that is the final, and v1x is representing before the collision the x component velocity. Since the body is started from the rest now, hence v1x is equal to 0 and V2x is equal to 20 into cos 30 values now. On substituting these values in the equation now, Fx into time is equal to 0.02 equal to mass is equal to 0.2, final velocity minus initial velocity. This is the change in velocity now, which is equal to Fx is equal to 0.2 into 20 into cos 30 divided by 0.02, which is equal to 173.2 newtons. Similarly, in y directions now, Fi into t is equal to m into v2y minus v1y, where the Fi is representing the component of velocity, component of force which is acting in y directions, and t is the time taken for impact, which is equal to change in momentum in y directions, m into v2y is representing the final component of velocity after the collision, that is the final velocity. v1y means the component of velocity in y directions before the collisions now. On substituting the values, we got to Fi into 0.02 is equal to 0.2 into 20 sin 30 minus 0. On simplification, we got to Fi is equal to 100 newtons. So the resultant force is given by F is equal to under root of Fx whole square plus Fi whole square. From this relationship, we got approximately 20 newtons. Since the force is a vector quantity, hence it should be represented both in magnitude and directions, and so theta is equal to, we can write it tan inverse of sigma Fi divided by sigma Fx, or Fi divided by Fx. It is equal to tan inverse of Fx is equal to Fi is equal to 100 divided by 173.2 values now. Okay, this is the equation to determine the magnitude as well as the direction of the force which is acting on the ball. Similarly, in second problem, so the figure shows a ball of mass 125 grams moving in horizontal directions towards the bat with a velocity of 20 meters per second. The ball attains a velocity of 32 meters per second at an angle of 30 degrees with respect to the x-axis when hit by a bat. Find the impulsive force exerted by the bat on the ball if the direction of strike is, the duration of strike is 0.025 second. So the given data in the problem is the mass of the ball is given 125 grams, which is equal to 0.125 kg. The initial velocity, since it is moving in horizontal directions, that means it is represented only with the x component. That is v1x is equal to, that is 20 meters per second, that is in horizontal directions. v1x is equal to 20 meters per second, and v1y is equal to 0, since it is moving in horizontal directions. Just after hitting with the bat now, the ball moved with a velocity of 32 meters per second with an inclination of 30 degrees with the horizontal. Hence, resolve the velocity into two components, x component, y component. So the final x component is given by v2x is equal to, according to these problems now, it is resolved 32 meters per second into two components, that is x component, y component. This angle is given 30 degrees now. Hence, v2x is equal to minus of 32 cos 30 degrees and v2y is equal to 32 sin 30 degrees now. Duration of strike is equal to t is equal to 0.025 seconds. So according to the impulse momentum equations now, that is impulse equal to change in momentum. Impulse is the product of force to time in one direction should be equal to the change in momentum in the same directions. Here we are taking in x direction now. Fx into t is equal to m into v2x minus v1x. So Fx we have to determine. The time is given 0.025 seconds equal to mass 0.125. Here the velocity is given, which is equal to minus of here 30 cos 30 and minus again 20 degrees now. It is now representing, that means the change in velocity, that is we required v2x minus v1x now. Here both are moving, that is here the object when it is moving toward the left side, assume it is a negative sign now, that is negative minus 30 minus 32 cos 30 minus of positive 20, that is it becomes minus 20. From this relationship we got to minus of 238.56 newtons now. Similarly, for Fy directions now, Fy into T is equal to m into v2y minus v1x now. Since it is moving in upward directions, assume the velocity is having positive, and so it is equal to Fy into T is equal to 0.025, m is equal to 0.125, 32 sin 30, it is representing the final velocity in y directions, minus of 0 because it moves in horizontal directions earlier now, so y component is equal to 0 now. So from this relationship we got now Fy into T is equal to, and substituting the values we got to 80 newtons. So the resultant force is given by F is equal to under root of Fx whole square plus Fy whole square. From this relationship we got, which is equal to 251.6 newtons now. And theta is equal to, we can take it as a tan inverse of 80 divided by 238.56 now. Since x component is negative, y component is a positive, it belongs to second quadrant, and so theta is equal to, we can take it as 180 minus this values, which is equal to the angle measured in counterclockwise direction, so from reference line now. Here the conclusion, the momentum is the fundamental quantity. It is a vector quantity like force and energy. It is possessed by the body when it is in the motions. And it is a vector quantity which is acting in the direction of motion of the body now. The term momentum and linear momentum will be used interchangeably in the test now when the body is moving in linear directions. The momentum is the product of velocity and mass, hence it depends upon mass as well as the velocity of the body now. Okay, impact. Impact means here not treated as a collision now. Here, in order to define the property of elasticity, just I am taking one is stone, one more is the ball now. When the ball is hit on the ground, it will rebound up to a certain height now. But when the stone is hit on the ground now, it will not move above the ground. The property of which it will rebound when it is hit on the other surfaces or on the ground now, it is called elasticity now. If the body which rebounds to a greater height is said to be having more inelastic than the object which rebounds lesser height now. The body which does not rebound at all after its impact is called inelastic body. The phenomena of collisions. When the two bodies are collide with each other now, The phenomena of collisions take place as given below. The two bodies, when they collide each other, after the collisions, come momentarily to the rest. The two bodies, when they are coming before coming to the rest, they are compressed each other so long as they are compressed to the maximum value. After compressions, again they separated by regaining its original shape due to the property of elasticity. The process of regaining the original shape is called restitution. That means here the phenomenon of collision is taking place when the two bodies are colliding with each other. Momentarily they are coming to the rest at a certain state, but before coming to the rest, they are compressed each other to the maximum extent. After that, they will regain its reshape after some time. The property of the body by virtue of which it regains its original shape is called elasticity. The process of regaining the original shape is called restitution. The time taken by the two bodies in compression after the instant of collision is called time of compression, and the time for which the restitution takes place is called time of restitution. The sum of the two times of collisions and restitution is called the time of collisions or period of collisions or a period of impact. Law of conservation of momentum. The total momentum of two bodies remains constant after the collisions or in other mutual actions. That means mathematically, when the two bodies are collisions each other, the initial momentum possessed by the bodies before the collisions is given by m1 u1 plus m2 u2. It should be equal to the momentum possessed body after the collisions m1 v1 plus m2 v2. This equation is only satisfied when the resultant force which is acting on the body should be equal to 0 now. That is the impulse equal to change in momentum now. Since the change in momentum is equal to 0 means the impulse is equal to 0. Since the time is not equal to 0, hence we can say R is equal to 0 or the system of forces which are acting on the body when the collision process is taking place is treated as 0 value. Newton's law of collision of elastic bodies. When the two moving bodies collide with each other, their velocity of separation will be a constant ratio with their velocity of approach. That is, here I am taking now, here the two bodies are there now, they are moving together now, they are now colliding with each other now. The velocity with which the two bodies are separated, after that two collisions now, compression is taking place. After that, they regain its original shape and separated with each other now. They are just moving again with a certain velocity. Assume it is a v1, it is a v2, u2 and u1. Assume. The velocity of approach is given by the difference of velocities of two bodies before impact, that is u2 minus u1, that is treated as velocity of approach, and v1 minus v2, the difference values of these two are treated as velocity of separation. According to the Newton's law of collisions, the velocity of separation is always be as a constant ratio with the velocity of approach. That means v2 minus v1, it is called velocity of separation. It is equal to e into u1 minus v2. This is treated as velocity of approach, where e is the constant of proportionality. And this constant of proportionality is also called the coefficient of restitution. Here I am representing here two bodies now. One is having mass is equal to m1, which is moving initial velocity u1 towards the right hand side directions linearly, and u2 is representing the velocity of second body, which is having mass is equal to m2. Since u1 is assumed just greater than u2, they are impact with each other now. In this process, the velocity of approach is given by u2 minus u1. After the collisions, that is the first compressibility taking place. After that, it regained its original shape because of property of elasticity. Now again they separated with a velocity of v1 and v2. Then velocity of separation is given by the difference of v2 minus v1. So according to the law of collisions, Newton's law of collisions, the velocity of approach is always a constant ratio with the velocity of approach. That means v2 minus v1 is equal to e into u1 minus u2 now. A little consideration will show that the impact will take place only if u1 is greater than u2 now. So velocity of approach is given by u1 minus u2. Similarly, the velocity of separation is given by v2 minus v1. As per the Newton's law of collision of elastic bodies, v2 minus v1 is equal to e into u1 minus u2 now. If e is a constant proportionality, generally it is called coefficient of restitution. Its values lies from 0 to 1 now. It may be noted that if E is equal to 0 now, the two bodies are treated as inelastic. And if E is equal to 1, the two bodies are treated as perfect elastic.
Like, share and subscribe. Hit the bell icon for more updates.